The next thing we're going to learn about terms to describe waves, or in this case to describe points on a wave, is phase. Alright, so phase. Basically, one way we can describe points is to say that points of a wave are in phase. So points along, what does that mean? Points along a wave are in phase if they have the same direction, speed, and displacement from the rest positions. So what does this mean? Let me show you a short clip here.
Notice that points A and B always have the same vertical displacement and they are moving in the same direction at same speed.
Right, so
this means that A and B have the same phase of vibration.
That's right, thank you very much. So 2 points in phase would look like that. They would constantly be moving.
Notice that
they would constantly be moving together. So if you see that they're in phase, this is what it means, right? So they're always moving simultaneously. They'll be at the same displacement at all times. They'll be at the same speed at all times, and they're moving in the same direction at all times. So that's what 2 points that are in phase mean, right? So yeah, if you notice, do you notice that the 2 points in phase are exactly one oscillation apart, right? Yeah. So we'll talk about that later, but yeah. So if you look at this, right? Of course, that was a moving video, but what about a static in a displacement distance graph? Can you identify points in the graph that are in phase with each other? So let's start with the example of P. Which point is in phase with P? Which point or points are in phase with P? Right. So it has the same displacement from the rest positions. So obviously it's either it's either S or V, right? So P, S, and V all have the same displacement, right? It's the same displacement. All right. Maybe I should use a pen here, right? So they have the same displacement. And then are they all do they all have the same speed? So displacement is checked. Do they all have the same speed? Well, let's look at it. At the highest point, what is their speed? If you remember, at the highest point of their motion, all of these points have the same speed of 0, right? They're all momentarily at rest, so they're all the same speed. Do they have all the same direction? So are they moving in the same direction? What direction is P moving next? It's going to move down, right? So P is going to be moving down, S is going to be moving down, V is also going to be moving down, right? So all 3 points, P, S, and V, they're all in phase, right? They're all in phase. They're all in phase with one another. Right, can you identify another pair of points that are in phase? I think this is pretty straightforward. Q and T are probably in phase. Okay, let's do R and U first. R and U is the more obvious one. So R and U are in phase. They have the same displacement, they have the same speed, momentarily at rest, and the same direction, both moving up. Alright, what about QT? So QT, displacement is both 0. The speed, both have the maximum speed. Direction of movement, are they both moving in the same direction? Alright, so if the wave is moving in this direction, right, the hand is here moving the string up and down. So at this point, he's going to be pulling down, right, to continue moving the wave in this direction. So the hand is moving down. So these points are going to be moving down, 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 down. That means that these points are going up, 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 up. I hope you can kind of figure out what I'm doing. If the wave is moving this direction, that means that Q is going to be moving up. Alright? And of course, this means that all of these is moving up. Then these will all be moving down. Rest, and then this is moving up. And so by the time you reach here, T is also moving up. Alright? So you see that, hey, Q and T, what's happening? Q and T are both moving up. So they have the same displacement, speed, and direction. So Q and T are also in phase. Alright? I think just now I pointed it out. If you've noticed, basically, things that are in phase have to be one complete oscillation away or more. Okay, so I guess it's not really one, but a whole number, right? Whole number of complete oscillations away are in phase. So P and S is one oscillation away, P and S are in phase. P is also in phase with V, it's two oscillations away, and S is also in phase with V. Alright, so with this understanding, right, let me ask you a question. If I have a point here, let's call this, I don't know, X, alright, Y. Is Q in phase with Y? Is Q in phase with Y? Alright, so using this kind of idea here, there has to be a whole number of complete oscillations away. You know that, okay, this is only half an oscillation away, so they're probably not in phase. Okay, but this is just, the real definition, of course, is looking here. So let's look at this, right? Does Q and Y have the same displacement from the rest position? They do, right? The displacement is 0. Right? Do they have the same speed? Yes, they do have the same speed. Both are moving at the maximum velocity. But here's the part. Are they moving in the same direction? Alright? So you realize that no, they're not. Right? So because if he's pulling the string down to move the wave from left to right again, that means that Q is going up and Y is going down. So they're moving in different directions, so therefore they are not in phase. Okay? So do points that are in phase have to be either at the crests, troughs, or origins? Okay, no, they don't have to be. A point here will also have another point on the graph in phase. Another point on the wave in phase, right? The other point will be here. These 2 points will have the same displacement, they have the same speed, and the same direction, right? And I guess if you follow this kind of guide, general guide, this is exactly one oscillation away. So this point here will also be in phase with these other 2 points, right? These 3 points will be in phase with one another. So any point on the wave will be in phase. You'll be able to find another point somewhere along the wave that's in phase, alright? But usually we look at the crests and the troughs for this. Alright, so I hope that was clear for what is a phase, what does in phase mean. Alright?